Hello everyone, my name is Kushal Zope from VRT and today I am going to design PCB for a flight computer of our model rocket. So first let's begin with placing the components and first component will be a voltage regulator which is TLV 7673 BTRVT. Okay, this one place. Okay, place. This is our voltage regulator. Uh, let's name it ESP32 S3 room and 4R2. One UN coil. Okay, let's place it. 7 volts later down. This one. Let's see. Written in Chinese. But yes, this is the one we are using for our place. Okay, your concept. Let's name it GU. And now the next component will be our barometer, which is MX5611. MX5611. Search for it. This is the one. Let's take it out. It's not available. This one is available, right? Okay. This is our barometer. Let's name it baro. Okay. Let's name it all capital. Fine. Now the next component is IMU, and we are using actually two IMU, one for high G and one for low G. So for high G purpose, we will be using ADXL 375. ADXL 375. Let's see. Uh, so this one, yeah, 3H6, 200G, and this one is let's place it. Uh, and say here, mm, let's name it IMU point. Okay. And now the next IMU, which for the low G, is ICM 42688. ICM 42688. Look, here it is. Let's place. Let's place it over here, right next to it. Okay. Now, next component will be our GPS, which is Max M10S. Max M10S. It looks like it is this one. Let's try placing it. Yes, this is the one. Now let's name it ICM, which is IMU2, and then this one GPS. Now for this GPS, we will be adding antenna. For that, we will need a UFL connector. So let's search it up. UFL, which is not connected. U dot SL R SMT. Hmm, out of this one, let's place this. Well, this does not look right. Um, we did this one. Let's try placing it. No, do this one. Yes, this is the right one. Let's place it right next to it. Okay, meet up. Yes, fine. Now the next component is SD card. Oh, my bad. Sorry. So for SD card, I have its name 4721920001. Now, yes, look, this is the one SD card slot. Let's place it here. Okay. Currently, I'm not organizing it very properly. I'll do it once I start placing the components and start doing the connections. For now, I'm just placing the components. Okay, card. Where goes the card? Right, I'm gonna name it SD card. Okay, and now the next one is USB. We are using USB. Okay, now the next one is USB. Which is exactly this one. This first one is the right one. Okay, let's plate sheet. Okay, now this is done. We will be adding more passive components as we go on to do the connections. But before that, I think we should name our PCB. That is NAVION. Okay, place it here. Uh, It is quite small. Let's say 5. No, and this is good. Okay, now after NAVION, first we will start with power system. Okay, let's keep everything aside as of now. For power system, actually the thing is that I will be taking 5 volts from the power management board which is present in our model rocket, and that 5 volt will be converted into 3 volt by this voltage regulator. Okay, so let's rotate it a bit. Okay, from this side that 5 volt will come. Okay, so for that we will have to provide one screw terminal, 2-pin screw terminal, one through which main 5 volt will be given and second one will be ground. Okay, so let's search it up. BB 125 3.81 RD. I believe this is the one. Yes, this is a 2-pin screw terminal which we are going to use. And here comes the first. Let's rotate it. Okay. Uh, for more understanding, let's name it T1. Okay, terminal 1. And this is the name. Let's get little inside. Okay. Fine. So then for wire, first one is here. Okay. Let's say this is the 5 volt incoming. Make it great. A little distance. Fine. And second one will be ground. Uh, for ground. Okay, so now the next part is ground. So for that we will just press G, put it here, where is it? Ground. Okay, then next ground here and here. Okay, we can move it up. Okay, fine. Also this ground has to be moved. Alright. Okay, now the next part is out. Okay, so the main thing is from this terminal, 5 volt will be coming and 3.3 volt will be going outside. Okay, and this feedback, for now we don't have much use of feedback, hence we are just going to connect it to the out one. Okay, now the next one is EN, which I believe will be connected to 5 volt over here. uh, EP will be going to the ground. Okay, here comes the ground. Okay, okay, now this out will be accompanied by capacitor. Let's place it up the capacitor. Okay, and over here it is fine. Turn it down a little low, and capacitor the value is one here. Okay, now Sorry, this will be 2.2. I just checked in the data sheet of the voltage regulator and output will be decoupled by 2.2 farad. And then ground, let's take up. Okay, then wire over here to here. Okay, this will be 5 volt from USB, and this will be other one. Over here, we will be adding our capacitor, icon capacitor. Okay, sorry, should I ground a little lower and then wire it to the common ground. Okay, this one is, I know it's the same, but I prefer keeping it at 1 year. Okay, now the connect label over here, this goes at plus 5 volt. Okay, now another net over here, take it a little closer. Okay, this will be 3.3 volt. Okay, this is it for the voltage regulator. Although one more part is left, and that is for LED. Okay, just to there will be one LED over here, which will indicate that we are getting 3.3 voltage. Okay, so for that, okay, so for LED, we, okay, so now the next part is LED. This is the LED. Let's place it over here. And now next we will need one resistance. Be careful that resistance has to be of 220 ohm for LED. Okay, it is done. Let's name it LED one. Fine. Take it up and then move a bit. Alt W. Wire it and done. Now it looks like our power system is done. So from here, the 5 volt will be incoming and going to the in terminal of voltage regulator, and 3.3 volt will be coming as a output, which we will be using in whole of our PCB. Fine. Now let's just name it as a power over here. This one power. I want it to be a 5 mm. Use it over here. Done. Now I think we can shorten it a bit. It's a little too wide. Okay. Select it up. So we know this won't be a good. Fine. Move will be a bit too. This is good. Place it over here. Move it a bit. Okay, fine. Now the next part is, let's say, barometer over here. Okay, let's place the barometer. Fine. Okay, now for the barometer, uh, there are some pins. VDD goes to 3.3 volts. this one PS. Now this is the protocol select, so it is very important to do the connections carefully here. So the PS is protocol select for because this MS5611 works on both I2C and SPI protocol. So for I2C protocol, which I am going to do, I have to move this to 3.3 volt as well. Okay, so let's net it. Okay, level, look here it is 3.3 volt. Fine. Same for this one, 3.3 volt. Okay, now the next one is ground. Obviously, it will go to the ground. Fine. Now the next is this sheep select. Okay, sheep select is also for and now the sheep select is also for the protocol selection. And again, since we are going to do I2C, both the CSB has to be 3.3. I think let's just connect. Uh, okay, my bad. Something was wrong over here. I can't delete this. Ah, PW. Okay, that both are connected. Move it with this one. Okay, all to the queue. Move it little ahead. Take it down. Okay, now the both CSB are interconnected, and we will move. Okay, we will keep this also as 3.3 volt. Okay, now what is left? HCL, SCI, HCL, SDA, and SDO. Okay, SDO is for the address of this barometer. So it is our choice whether we want it to be high or ground. So for high, the address will be 077, and for low, the address will be 076. So let's keep it 077 here, and again 3.3 volt. Done. Okay. Now the HCL and HDA, it has to be kept as it is. Oh, wow. Sorry, my bad. This one. Okay. Tag it here, HCL, that's it for HDA. Okay, now I'm going to do the common pull up, pull down on the MCU. Hence, we will do that later. But right now, I have to decouple this VDD one. So for that, I will need one capacitor. Here we go. Okay, here the one GMD. Comes. Okay, uh, this will be of 0.1 microfarad. Okay, done. think now this looks perfect. The barometer is also done. Now the next component will be, let's keep it IMU1. IMU1 over here, and we will do IMU2 over here. Fine. Okay, so first we will do the connections for IMU. So for IMU first, alt wire VDDIO. This goes into 3.3. It is reserved ground. VS chip will also go into VDDIO as 3.3. This is the main supply pin, and this is input output pin. So both has to be done at 3.3 volt. So I have connected them both together. Okay, now the next one is here shift select. We go shift select, and the shift select actually decides the address of adxl, and if we ground it, it becomes X053. Okay, and then let's make a here common ground. Okay, alt W. Oh, sorry, delete. Okay, here goes this one, goes this one, and here goes this one. Okay, we will not touch the reserved one. Okay, reserved one has to be closed. Same way here. INT also we don't know. NT also we don't need. Okay, now SCL and SDA, obviously the common wires for us. Okay, again this is oh sorry, my bad. SDO is for the address, that is if we do this ground, it will get 053, while this CS was for the protocol select actually. Okay, my bad. I'm very sorry. For protocol wise, we are following I2C, so CS has to be done at 3.3 volt. Um, Very sorry. 3.3 volt. Okay, now this is done, and then SCLSD, take for the SCL, this will go at HDA. Okay. Okay, I forgot one thing, that is we have to decouple that VDIO. Okay, let's move this ground over here, expand it a bit. But I forgot to name it. Right, this one. No, 3.3 volt. Okay. Mhm. Right, capacitor. Fine. Now ground. Over here. Let's stretch it down a little lower so that it is clearly visible. Okay, this is Q4, and value has to be 0.1 microfarad. Okay, done. I think a bit over to. Okay, fine. This is great. I think. Okay, let's name it over here. ADXL. Next, I think Varo. Okay, this looks good. Now the next one is second IMU, that is ICM 4268. Okay, now for this ICM one, first of all, let's close all the reserve one. Okay, reserve we don't need. INT we don't need. Reserve we don't need. Mm, again INT reserve. Okay, fine. Now VDD, this goes to 3.3. VDDIO, this also goes to 3.3. Um, SDO is for the address, and then HCL is lead. Fine. And then ship select. Okay, ship select is for protocol selection. Fine. Now that level 3.3 volt. Fine. Oh, I forgot about the ground one. Would have a little further. Uh, fine. Okay. Next chip select. Okay. This is SDA. This is HCL. Okay. Hmm. That table over here. Okay. CS also has to be 3.3 volt for I2C protocol. Okay. Now the next is SDO, which is for address. I'm grounding it. So by grounding it, the address becomes 068. Okay. Now VDDIO that also goes for 3 3.3 volt. Fine. Uh, the second IMU is also done. Except few decoupling capacitors are left. Uh, Here goes for VDD, VDDIO. And now I just viewed into the data sheet, and there are two decoupling capacitors for VDDIO. Sorry, two for VDD, not VDDIO. Okay, this is second one. Extend it a bit. Uh, then come a little lower. Okay. Um, then it this side. Add another one over here. Okay. Now for the value. Okay, so this one is 10 nanofarad. Okay, I forgot the ground. Oh, fine. Uh, One is 2.2 microfarad, and another one is 0.1 microfarad. The ground are left. Here goes first ground, second ground. Okay. So now our second IMU, that is ICM, is also done. Now next, I think let's move it. I think this ADXL one, we should move it a little bit over here. Right, yes, this is fine. Um, yeah, okay, looking good. Now next, I think we should go with Max MS10. And to keep in mind, we have a UFL with it. Okay, Okay, now let's move on with GPS. First of all, I will close all the terminals which we don't know, don't need. Okay, first is save boot, EISL, and FIN, you don't need to reset, we backup, VIO, time call. Okay, also we don't need extend. Hmm, wait a minute, as of now, think look, SQL SDA, VCCRF, GND, RFIN, GND. This looks fine. So actually here we will be using both UART and I2C protocol. First, let's reverse it. Okay, this is better. So the thing is, we are mainly using I2C protocol, but in case I2C doesn't work with GPS, we will be going with UART. So for that, I will be giving a separate route for RxTX also, which will be connected with 0 ohm resistor. So naturally, it the whole line won't be connected, but unless and until we solder it ourselves to go with UART connection. First, let's do one thing. Go with ground. Okay, and move it. Fine. Ultimately, ground over here. SPLSD. Equal SPLSD. Let's keep the register over here and over here. It PC center and hmm, is 0 or rather just write it 0. Okay, 0. This is fine. Okay, this is fine. And uh, then ground to this one. Hmm. Hmm. Okay. So this will go to SCL. Okay. Let's take it to the center of it. Okay. Now VCC RF goes directly into SIN. Okay. Well, not exactly like that. First, we have to place RFIN into here. Okay, let's move it further ahead. We have to decouple it well, obviously, and let's forget it. Decouple it with 47 picofarad of capacitor. This is fine. Move over here. 47 picofarad. This value is actually given in the data sheet, okay? Fine. Now VCCRF. Okay, VCCRF goes into an inductor. VCCRF goes into the okay inductor over here. Okay, it up, included it. Okay. Mm, it goes to 27 nanohenry. Okay. These are all standard values and given in the data sheet of Max M10S. Okay. This comes here. VCCRF goes here, and through this it connects RFIN and goes directly into SIN. But before that, this VCCRF is decoupled as well as pulled high. So uh, I will have to bring a capacitor first, and okay, here comes the capacitor. Let's okay, sorry, not quite like this. Okay, I don't know. Well, hmm, we'll do one thing. Fine. Uh, and we will need another wire which is to be pulled high. Okay, now comes the capacitor. uh, keep it over here. Okay, and then comes the resistor. Mm, okay, okay, the value of this resistor is just 22 ohm. This is given in the data sheet right here. Okay, oh, sorry, not 22, it's 10. This is a point 0.1 microfarad, and obviously it has to be grounded. And this one is pulled high, so we'll need a wire and a net label of 3.3 volt over here. 3.3 volt. Okay, with this part is done. Now over here Uh, this, okay. Let's label it as RX underscore. Now VCC and VIO both will go for 3 volt. Sorry, I mean 3.3 volt. Okay, but this will be decoupled, of course. Um, the value is 0.1 microfarad. Grounded. Okay. Now the net label for both to be 3.3 volt. Okay, with this, obviously these two grounds are left. Sorry. Okay. Here comes the ground and here comes another ground. Maybe. Uh, okay. Okay, this is clear. Now this is done. Our GPS connections are completed. Now we are left with very few MCU. Let's keep MCU over here, SD card over here, and the USB over here. Okay, fine. First, let's go with SD card. Okay. First, let's start with the useless pins. This, 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 this. We don't need that zero. We don't need that two. Oh, sorry. I mean, delete this one. We need that zero. We don't need the one. Okay. The first one is CDCS pin. On the wire. Mm, This will be named as CDCS. CD slash CS. Okay. Now it will be pulled high. Value is 10K itself. Okay. Mm, okay, this is 3.3 volt. It is pulled high. Okay. Now similarly, CMD, it is actually Mochi pin. It is also pulled high. Um, okay. Again, this will also be pulled high with 3.3 volt. Okay. Now, now the next one is VDD. VDD will go to 3v3 directly, but it will get decoupled by 0.1 Farad capacitor. So we will need a capacitor over here. This is it. What is it? This comes around. This is here. 0.1 microcontroller. Cool. Now, now the next one is CLK. It is simply one of the protocol line. It will directly go to CLK. The next one is VSS, which will go to the ground as a chip select. And then that is a MISO. Master in slave out. MISO. Okay. It is also pulled high. Okay, fine. Level. It comes to 3.3 volts. With this, our SD card is also done. Okay, more readable. Fine. Now the next one is USB. USB is quite difficult actually, but no worries, we will do it. So towards the last part, USB. Uh, so first of all, assets will be ground. Let's see it here. Okay. Uh, These assets will also be grounded. Then obviously this is ground. This is ground. So, okay. Ground is done. Now all the V-bus will be also connected with one another. First, I will make this one as a main V-bus. Okay. Now connect it along with that. Um, Here we go. There. Okay. All the V-bus are connected. We don't need HBU pins. That is done. Now, bus is will go to 5 volt actually. This will supply 5 volt. That's 5 volt. Okay. And it will pass through diode. Okay. like this. It to GP. So let's do one thing. Let's move it a little bit over here. Okay. Okay, then CC1 and CC2 both will go through 5.1 kilo ohm register to the ground. Okay. Uh, let's add the register over here and then over here. Place it in between 5.1 feet. Okay. So similarly, this will also go here with 5.1 K. Both will be passed through now. Okay. And this is done. Now the next part is DP1 and DP2. Okay, DPDN both will be connected at once and they will move to pin of MCU. Okay, so I will allow, let's just say here is okay. DN DN1 and DN2 are connected now. Okay, similarly I will have to connect DP1 and DP2. Here goes DP2, DP1. Okay, both are connected. Now same as V, but I will have to put two diodes over here. One for DP and one for DN. Okay, both will end to DND. Okay, W. This for DN. Oh wait, this for DN. This for DP. Fine. Hmm. Okay, now I think it is completed mostly. Except now there will be two resistance. One here and one here. Now I think is hmm, that is standard and even in data sheet that the both resistance should have value of 22 ohms only. Let's keep R11 over here and R10 over here. Okay, now they will go to USB D plus and D minus. Here comes one. Here was another one. Okay. This is DP. Okay. Then this is DP, which means USB D flush. Okay. And this will be USB B minus. Okay. With this, our USB connection is also done. Oh, it just came to my mind that the diodes were actually wrong. The correct diode is this one. Uh, okay, it is over here. Place it. in One, two, three. Okay, just delete it. Uh, so we will place this one over here. But remember, instead of D4, this will be D1. Okay, similarly deleted D3, D2. Okay, but we can even delete it. Okay, that is fine. Then this one D2 and this one is D3. Okay, now our USB circuit is also done. Now MCU is the main. Well, now there is not very enough space because I also have to add two buttons, one for reset and one for boot, as well as few other terminals, one for communication system and testing lines. So the space will not be enough, hence I have created second page. So we will be moving there. But before that, I would like to arrange it properly. Okay, here comes the MCU. And for the first page, I think wait a minute. Okay, it is move USB here is here the carbon. Okay, I think this is fine pretty much. That is okay. Then comes the second page here. MCU. Along with that, I have to get with buttons and more screw terminals for testing lines and communication system as well. Okay. So for button, this is the name. Oh, sorry, this one was diode. And, okay, uh, here goes component. So this one is the button. We will need two of those buttons. One for boot and one for reset. And then I need a screw terminal for communication system. This is a 3-pin screw terminal. I would need a 4-pin as well. So instead, I just write a 4 over here. So here is a 4-pin screw terminal to place it. Okay. For the pyro section, uh, I will need more of open over. Hmm. One, two, three, four, five, six. I will need six of these two pin screw terminal and four of these MOSFET. One, two, three, four. Okay. I will arrange them later, but this is it. So for now, let's name our terminal first. Uh, Here was first terminal. Okay. So we only use one terminal so far. And then let's name it Q2. This will be Q3, Q4, Q6, Q7, Q8, Q9, and Q10. Okay. As well as these are MOSFETs. So M1, 2, M3, and this one M4. Okay. So now let's move ahead with T2 as here. Okay, this is a farm system. Okay, this means that through this terminal we will be sending our data to communication system. Okay, so I'll wire because all of our protocols of all the sensors are in I2C connection. We will easily be able to do it like this. We just need three pin terminal. This one has a CLC. Uh, CLC. Okay, and this one will be HDAC, and the last one this will be ground. Okay, now the next one are testing terminals. So that this one 4 pin and another 3 pin one. Okay, first, second, third, fourth. Okay, so what will we need here is well to make it clear. Okay, let's load it a bit. Uh, here, then here. Fine. Now, that level. First of all, this is the mochi, show, delicious, the CLK. Okay, so here, this one, background. Okay, sorry, that was just HCL. Okay. Now, now the thing is, I'm ordering this in particular order because while designing the PCB, it will have to be in certain order. Which we will understand when I will design the PCB why I am making this in a particular order. Okay. So the first one is Mochi. Okay. So sorry. The first one is CDCS. Okay. Second one is Mochi. Third one is CLK. And last one is Miso. Okay, now why I have done this in this particular order, it will be known to you when I will be designing the PCB. Okay, but it is just for the orientation sake, or you can keep it in any order as you want. Okay, so these are the testing terminals. Now the buttons are left. Okay, so for button, uh, well, first of all, you have to do this. Okay, and then for now, keep this over here. Okay, and the ground will be connected over here. Oh, and then through 1K resistance, this will move towards the EN path. Okay, so here we would this much, and then the resistance, it has to be 1K. Okay, and ultimately this will move towards EN. That is, this is a reset button. Okay, this will be connected through MCU, which we will be seeing later. And then at last, this has to be pulled up. Okay, uh, and yes, this resistance has to be of 10K. Okay, now same way, we have to make a boot button over here. Keep it to the side a little bit. Alt W. Okay, fine. This is to find this stuff here order resistance, um, add another resistance over here like this. Okay, connect it a bit like this. Then okay, fine. This is done. It has to be 1K. Okay, place it inside here. It's 10K. This is right. All W again. Uh, Now this has to be pulled high. Okay, means we will add two more net and both has to be 3.3 volt. Okay, same way here, 3.3 volt. And the this one will go to boot. Consider the ground with this. Our both buttons are also ready. Hmm. Uh, let's just name it. Okay, boot button. This is this one. Over this one and this one is reset button. Okay, fantastic. Let's also name this one testing terminal. Okay, over here. And now the next part is pyro. Okay. So for pyro, I am having four MOSFET. We will be doing two ejections. So I'm keeping two image for each ejection, hence four MOSFETs in total. Okay. Now let's just um, arrange it properly. So first of all, here will be two terminals for arming, and then one one terminal for each MOSFET. So like this. Okay, so for pyro over here now, these two terminals T5 and T6. Okay, okay. Um, this will be ground and this will be oh, power pyro 5E. Okay, this is just for the safety mechanism, nothing else. Then this comes and this will be pyro underscore 5E. Okay, Now, okay, now over here for each MOSFET, this will be the terminal. Uh, One will be ground, and and okay, for MOSFET, uh, this is gate, drain, and source. Okay, so let's have the text over here. Okay, G. This one is the gate. This is drain, and this is source. Okay, let's name it as, and this is drain. Okay. Uh, Now the source is usually connected to ground, and drain will be connected over here to this terminal. Okay. Um, Actually, here instead of this, this will be pyro 5V. Okay, let's extend it a bit, and we go pyro 5V. Okay, and this is the basic structure of a MOSFET, and for here, hmm, we have a gate. This one will be connected to MCU, and over here through resistance, this one will be going to the ground. Okay, that is pulled down. Okay, this is pulled down. It will be of 10K. There will be another register over here. This will be of 220 ohm only. Okay, and this one will be M1G. This particular line will be connected to one pin of the MCU, and similarly this way we are going to make all the other three MOSFETs and their connection with the respective terminals. Okay, so let's do that on this way, over here this way. This is connected to this. Um, this here and over here. Okay. Hmm. So this one will go inside. Again, this is 220 ohm, and the next one is coming to the, okay. See, then is 5 underscore 5. Okay. Uh, this one will be pyro 5 volt. Okay. Mm, oh, sorry. Net again. Pyro underscore 5. Will be down a little lower. Mm, this 320. And this one will be on 4G. Okay. Yes. Now, with this, our whole pyro system is done. And now all that left is just this one, MCU. Okay. This is the main part. So, first of all, starting with ground, obviously, then 3v3. Obviously, this will be connected to 3v3. Then this EN is of reset button. Okay, let's name it up. Volt, and this is EN. Okay, now direct to this one ground. Fine. This RX and DX, this one that we are going to use for GPS as a backup. Okay, it is not our main plan, but it will be still there as a backup. For a backup, okay, on TX we will be having RX of GPS. That is okay, this one RX GPS. And on the RX of MCU we will be having TX of GPS. Oh, okay. Now this 3v3, it will be oh sorry, mm, not the resistance, need a capacitor. Okay, it has to be decoupled over here. Ground, fine. Uh, as needed, I think we will move this a little below. Okay, this is fine. And that this will be 0.1 microfarad. Oh, 0.1 microfarad. Okay, okay, now this IO4 and IO5 are track pins, so we have to cancel them. Then this will be HCl HDA, but remember we have to do the common pull-up for them, okay? Since we have a lot of space over here, we will extend it a lot. Uh, they get fine. Okay, the resistance has to be of 4.7K. Same here, 4.7K. Uh, when the it is outside. Okay, this is and hard wire this way and this way. This is this here and over here. Okay, this is HDA, this is HCl, this is 3.3 volt, same here, 3.3 volt. Now 19 and 20 are USB D minus and D plus. Okay, 19 and 20. Hmm. This is USB D minus. Okay, and this is USB D plus. It is actually a default pin and it is given in the data sheet of this MCU S3 Bloom. Okay, now since we don't really have a use of the other IO pins, we will drop them up. Hmm. Okay, then this is also ground keypad. This will be okay. Hmm. This is HDAC and this is CLC. Okay. Hmm. Now we have uh, over here Mucho. This one is CLK. Okay, not CK. CLK. Okay. This one is Moti and this one is CDCS. Fine. Okay, then IO0 is the boot. Um, okay, and we will pass on LED through this project. LED. Wait, I have on the project. This one. Place. Okay, I will place one LED over here. This will go directly to the ground. Obviously, there has to be something. Wait a minute. I have to put one resistance over here. Okay, now fine. This resistance has to be of 220 ohm because it is for LED. For LED, we have standard resistance for 220 ohm only. Okay, now our MOSFET terminal lines are remaining. We will do from here 41, M1G, M2G, M3G, and M4G. Okay, M4G. Okay, this one will be M1G, M2G, this will be M3G. Okay, now I think our MCU is also completed. Let's close all the remaining pins. Okay. Hmm. Hmm. Okay. With this, our schematic is completed. And now next we will move on to PCB. Hmm. Okay, so now that our schematic is done, let's move to PCB design. Okay. Mhm. Okay. First, let's make the outline. Planning on making it to be. And then let's say 60 and 90.5. And I want it to be corner in the rounded corner. So for corner radius, let's keep it 5. Okay, now this is ready. Hmm, Let's see from here. Yeah, well, anyways, let's keep it 5. Okay, so now the dimensions of this PCB is 60 into 90.5. First, let's place the pads at each corner. We go first, second, third, and fourth. Okay, now each of them diameter is to be 3, 3, 3, and 3. Okay. Let's also keep it in proper order. Here, that would be this. Okay, this is also fine. So this is also fine. Now let's have the inner diameter too for each. Okay, now this looks fine. So first, let's start by placing our MCU. Mm, it should be right over here, I guess. And the MCU. Okay. This is fine. And then the terminal, yeah, which one? It's here like DAC. Need it to be here very close. Okay. This is first. This is also perfect. Fine. Now the next one would be T1, which will come over here. Okay. Now, hmm, I feel like this is bit off. Let's move it a little deep. Okay. Hmm. Now next I want a two terminal. Okay, this is the one power pyro. Then naturally the other one. Okay, this two over here, this SCLSDA, let's keep it here only. Hmm. Now I'm planning on keeping all the MOSFET terminals on this side. So for that I will need T7 to 10. Here comes the 7 one. This side, this is 9. Move it. Okay, now I see that's seventh one. Okay, seventh one has to be here. Then the eighth one. And then the ninth and tenth one. I'm planning on keeping the two of them a little separate, and there will be a little gap among them, but that's just my specific design. There is nothing wrong with it. Okay, now that this is ready, I'm actually planning on keeping this voltage regulator over here and all those sensors, which is barometer, adxl, and ICM in towards this side, and GPS will be over here. Uh, Testing terminal will be here, I guess, and SD card and USB will be over here. I'm planning on keeping SD card to the back side of the PCB, which means the bottom layer over here. Uh, so let's see the mm, these are the testing terminals. Okay, let's see this one over here and this one over here. Uh, right, as you can see. Okay, so this looks pretty decent. Mhm. Now the next is USB. I think USB over here. It looks good, right? And then SD card. Hmm, all to be okay, something like this. Okay, wait, let's keep it like this. And at the top, yes, this looks perfect now. On the top we have USB, and on the bottom we have SD card. Okay, now comes the GPS, which will be over here, I think. Mm, something like this. Right, and then the UFL, this one. Uh, I'm planning on keeping UFL here like this at the corner. Good. Okay, now the next part is the voltage regulator. Where is the voltage regulator? Oh, here it is. Voltage regulator has to be right over here. Okay. Then next one is the barometer. I plan on keeping barometer over here. Next we have IMU1 and IMU2. I plan both of them on keeping over here in this area. So IMU1 over there, and then IMU2 will be um, sorry, yes, over here. Okay, fine. As of now, I think this looks perfect. Then next one is I get now all the passive components are left. Okay, the buttons are left. Sorry, uh, I want them to be right around here. I think this is a good fish. Okay, and then next one is I think MOSFETs are left now. So for MOSFETs, let's go. I think it will be good idea to right. Okay, M1 over here. Okay, this something like this. Okay, this looks good. And then I want my M2. Okay, here, okay, M2 over here. Fine. And then finally M3 and M4. Here will be M3. Hmm, fine. Now from the very last M4. Okay. Now almost all of the major components are placed. Now only the few passive ones are remaining. Mm, well, I will place them using the help of schematic. So first of all, let's take the page one, R1, C1, C2, and LED one. Okay, see, I can see this is C1 over here. It has to be around here. Okay, then R1 is also around here, and then LED one. Okay, this is it. It will be something like this. Fine, and then Now the next one is for IMU1. IMU1 is over here. We just need C4 for IMU1. C4. Uh, well, thinking here it is C4. Okay, right. C4 over here. And then IMU2. It needs C5, 6, and 7. So here comes this 3, 5, 6, and 7. Okay, we come over here and 6 and okay, here goes 6 and C5 and C7. Okay, now Barrow and IMU1. Okay, IMU1 needs C4 while Barrow needs C3. Okay, so C4 is over here. Um, that is fine. I think this one is here. And then I need C3, right? Here comes C3 and close to barrow, right? And then I need C2, where is C2? Well, C2 is required in power itself, right? So I have C1 over here, but C2, here comes C2. Because I think I need to clear up a little bit of space, maybe over here, something like this. Okay, fine. This looks good. Now that this was over, now mm, let's see. We've done this, and this. Now over here we will need R2, R3, and R4. R2, 3, and 4 near GPS. Here comes R2 and R3. Then I need R4. L1 and see 8, 9 and 10. 8, 9, 11 and see 10. Okay, all over here near this one GPS. Now I think GPS is also over. Now the next is SD card R567 567 and C11. Okay, R567 and C11. Okay, this will be moving to all three over here. Fine. Now coming back to the top. Uh, 567 and 311. Okay, SD card is done. Now USB D123 and 8, 9, 10, 11. Okay, let's see D123, 8, 10 and 11, 9 is over here. Okay, this all comes near 5. Okay, now this is done. And then next is for M1. Sorry, one. Okay. Even I need for MCU also. 24, 25, 26 and C12. Okay, these three over here and these two. Okay, this is what we need for K. And then C12. I think C12 is already given. Okay, then over here 16, 17, 18, 19, 20, 21 and 20, 22. Well, over here 16 and 17 comes near M1. 18 and 19 come near M2. 20, 21 near M4 and then 22 and 23 near M3. Okay, now let remain is 15, 14, 12 and 13. Mm, I seem to have mixed them I think it will be on page 2. Yes, near button. 12 and 13 near reset button and 14, 15 near boot button. Okay, these two over here, these two over here. So now our page, overall, this will be our design. Tracing and all will be our left. Well, I need to place them betterly, but more or less, this will be our design.
Uh, Hello everyone. So now coming to our last topic, which is tracing. Uh, so as you already seen, I have already placed all of my components, and this is the rough positions of every component which I have decided so far. And now let's just start with our tracing. So first one will be, I'm thinking of starting with the power lines. Uh, Generally for power lines, there are two power lines, right? One of 5 volt and another will be of 3.3 volt. So for 5 volt, I'm planning on the wire to be of around 0.4 mm. Let's see. Let's change the track width to 0.4. Okay. And now let's start with 5 volt from here to here. Okay. Now next is from here and 4. And I guess this is of, okay. So this is it for 5 volt, and next one are in USB, which we will do separately. Okay. Now let's change it. Now normally I am planning on keeping the tracing of 0.25 mm, 254 mm. Okay. First let's just change the position a little bit, maybe a position which can be very clear to us. Okay. From here, connect this 3.3 to each other. Hmm. Now the main thing about this design is to remember that components don't overlap on the footprint, and hmm, components should not overlap on the footprint. Okay. So naturally now you can see here I am stuck. This 3.3 cannot go here very properly. So I'll do one thing. I will delete this trace for now, and okay, I will reverse this capacitor. Now this will be a better option. Okay. Okay, this is done. And then next is from here to here. Okay. So now this is basically, let's also connect the ground of everything. Okay. because ultimately every ground will be connected to each other and they will lead to common ground. Okay, now, okay, now you can see over here there is another problem. IMU and 3v3 this way, we cannot provide a proper tracing to ground if this capacitor is over above the IMU. So I change its position a little bit according to my convenience such that tracing will be lot easier. Okay, now this ground to ground is very simple. And then next, 3v3, ground to ground. Again, there is 3v3 SCL and all. Hmm, okay, let's do this ground to ground. And from here, this get both grounds are now connected. And similarly, hmm, this ground will move over here. Done. Now, SCL and SDA are left as well as 3.3. Let's just connect 3.3 from here to here. Simple. Okay. Now, there is another one. IMU2. Well, let's first move it barometer. Wait a minute. There seems to be a problem. This LED one is not connected to anything. Let's check this in schematic. What is the scene of schematic LED1? Over here, LED1 is connected to R1 and then that is connected to 3v3. Hmm. Naturally, this should be, but there is no tracing over here for some reasons. Wait a minute. Since if this is connected, uh, let's save it. Okay, this is saved. And now, I think let's update the PCB maybe. Changes. Okay, here is the pin of component LED does not correspond to the pad. Pin has no corresponding pad. AK pad has no corresponding pin 1, 2. Okay, then the problem seems to be in the footprint of LED traps. Well, let's see. Where is LED2? Here is LED2. And yes, the same problem lies in the LED. Hmm. So there seems to be a problem in LED. Um, I think I will have to change the LED perhaps. Well, let's see. Okay, so there was a problem about LED, which I figured that it was the wrong footprint. Okay, so let's see the right one, which is this one. Okay, in the common library, you can simply search LED and you will get one. Just select this one. Okay, over here now this is LED one. Alt wire. Let's simply connect it. Okay, and now I will have to change the LED to also. LED to well, let's see project details. Okay, LED 2 is in page 2, I guess. Let's open page 2. Okay, yes, here it is. LED 2. Let's delete this one and the better one for you. Okay. Okay, now finally, I think the problem should be solved now. Let's update the PCB. Let's see. LED are changing. Okay, now let's see. Uh, okay, here are our LED. Hmm. Let's move our LED one over here and LED two over here. Okay. I'm very sorry for the problem. It was a very silly mistake of me to do that. But anyways, let's change the position a bit and alt wire 2.54. Simply connected. Okay, wait a moment. Turn off this. Okay. Now, it's just simple straight traces. Okay, now that this is done, let's focus on uh, barometer, I guess. Wait, not this. Um, take this one. Um, the moment, let's delete this. Alt wire. Uh, this is not coming very perfectly. Okay, anyways. Now that this is done, connect 3v3 to 3v3, 3v3 to 3v3, 3v3 to 3v3, and let's move this a little bit over here. Alt wire 3v3 to 3v3 and ground to ground. Okay. Now, well, the thing is, I will have to take ground. Yeah. Okay. Now, um, see over here we have this one ground to ground. Let's shift this a little bit. That's it. And then this to this. Fine. And now let's do this. Okay. This is very unfortunate. Now let's see 9, 10, 11. These pins are not connected, so it is okay to just uh, move it around here. Yes, there is a very important rule of tracing, that is you cannot make a 90-degree angle no matter what. Always prevent the 90-degree angle while doing the tracing. Okay. Then simply C3 over here. Um, See, ground, you cannot go over here, right? You will have to move through this, or wait a minute, you can simply go over here, right? Something like this. This is done. And then now what is left? Okay, these two grounds are not connected yet, which is also needed to connected, but this ground and this ground are yet to be connected. Okay, which will be connected if you connect this ground to this ground. In that case, 3v3 will be blocked. Okay, well, no worries. Simply move this. Okay, and now, um, what is next? Okay, these two grounds are still remaining. Okay, now, here's the trick. You can simply change the tracing to the back side of the PCB. Now, the benefit of our PCB is that hmm, we are planning on the four-layer PCB, and on the very back side of our PCB, there is just this SD card. So there is not much of a issue. We can do a lot of tracing on the back side of the PCB. Okay, so let's do this. Over here, alt back, or not like this. Pardon me. Back to top. Um, let's delete this. Okay, alt wire. Move it toward this side. And now alt back. Okay. Now you want to connect those grounds, right? Simply come over here, alt T, and boom, your grounds are connected. Hmm. Okay, now just notice that here a 90 degree is being created. Just delete this one, and from over here, select this. Okay, now this is fine. Um, now, well, we are kind of stuck over here for HCL and HDA because there is very less space over here. Let's do this very carefully. Um, for a via, alt B. Okay. See now here is a DRC violation, right? So you cannot do that. Hmm. Wait a minute. Let's just delete this. So I will have to delete this whole 3v3 track and perhaps even this ground one and shift my capacitor to a little bit over here. Okay. Delete this one too. Um, it is fine over here like this, I think. Right? This ground to ground. This ground. Okay. Now all that remains is this 3v3 to 3v3. You have to push it back over here. This is much cleaner approach, and for HCL, just like this. For SDA, it's better to keep a little bit of distance between tracing. It does not matter very much, but it's best to keep the distance as much as possible. Make the design clearer. By increasing the distance, you are basically uh, improving the noise efficiency. It just so that it will work a little better, nothing else. And then this 3v3 is remaining. Okay, this is a concern, but anyways, um, this is done. Now, as you can see, our whole IMU 2 is done except for this ground. Okay, for this ground, uh, well, what to do? Well, always there is always option of via through the layers. which is basically a concept. For example, there are components which are very far away from each other, and a net is not connected between them. For example, there is one ground over here, and there is another ground, suppose over here. Due to your design, there is a problem that this particular ground cannot be connected to this particular ground directly. So for that, there is one solution which is through via. Okay. Now via is basically simply a hole, and through which you can access the layer. Now the in our design we are planning on, as you can see, there are four. We will be planning on 4 layers. Okay. Now since there will be 4 layers, you can think like this is the top layer, then second layer will be of 3.3 net, and then third layer will be of ground net, and there is the last layer. Okay. So due to this, if there is a ground net, then you can simply pass a trace through via. Now due to this, what will happen if even if the grounds are not directly connected through via, far away connections can be easily done without much without much hassle of connecting all those wires, right? Then coming back to another point, SCL SDA again, this is a concern now. Let's see, we have 3.3 over here. uh, well, this one is connected, right? Okay, wait, so 3.3 is not an issue. Only two which are left are SCL and SDA. Okay. Now for SDA, you will have to move over here. For that, there is a very simple way which I already told, which is Alt B. Okay. Um, but for all, even for Alt B, you will have to trace it in such a way that it will not create much of a problem. Okay. Now over here, give come back to Alt T and simply connect it. Okay. Now that HD, HD is connected, let's move to um for this also we will have to do the same thing as we did for SCL, but there is a problem that you cannot put a via over here, right? Let's forget it. Come back to top, and let's change this SDA trace a little bit so that we can easily. Okay, now that this SDA is done, see, you saw my fault. It was a 90-degree. Okay. Now it is doable. Okay, let's switch over here. Hmm. Mm, how do you want to do it? Let's just shift over here, Alt T, and we shift it. Okay. Um, much better. Now again SCL and HDA, which will be connected over there, which is fine. Um, okay. For now, I think our voltage regulator is done. All its nearby connections are done. IMU1 is done, IMU2 is done, and also barometer is done. So there are some things which are left. As you can see, this ground over here. Let's see how this ground is connected actually, because it is important. Um, see. Okay, wait. Let's stop. Just um, connect this ground over here. Hmm. Make sure you connect all these grounds to each other. Oh, oops. My bad. What is this? Delete. Wait. Now. Okay. Fine. This is fine. Um. Now 3v3. Okay. 3v3 is done. Now for ground. This is the common ground one, right? Let's just see again. Which one are not connected yet? Okay. This is just a simple problem. Uh, hmm. Yeah, forget it. Come to bottom. Well, instead of this, okay, come over it this way. All up, and this is that. Okay. Ah, now our grounds are also done. SCL, 3v3 and ground. Okay, now first of all, let's just complete our USB connections. So okay, let's do the USB connections now because as you can see there is a USB D plus and D minus which will have to go through the differential pair. Hence, USB connection is difficult than other ones. Okay. Well, for now, let's see how the components are going. Um, okay, D1 and so D2 R9, and then I think we will understand better in schematics. Okay, let's just get it over. Okay, this was pretty simple. Um, ground to ground. Okay, wait a minute. Um, okay, this is 5 volt, and this 5 volt is going over here, and through this, it is going to here. Okay, that is fine for now. But I think we should first arrange the resistance. Okay, this is a different matter. Let's just shift the name. Okay, this is D plus and this is D minus. Okay, make sure you separate them a bit. Okay. Mm, And okay, okay. My bad. I just saw that D2 here has both the terminals to ground, right? Now this is a problem. This is not correct. Hmm. Let's move back and see D2. Well, what's the thing? One is over here D2, and the other one is going to R11. Then in PCB, why is this happening? R11, one is to US. Wait a minute. This is R11. Okay, this is R11. One is to USB and one is to ground. Okay. R11, one is to USB minus, and another one should be to the diode, not to the ground. Um, I don't know why this is happening, but I guess let's try saving it and update PCB. No changes. Schematics already matches the PCB. Okay. Huh. mm, Well, let's see what would D3. D3, I guess. Where is D3? Look, D3 is working perfectly fine, but there seems to be a problem with just the D2. How can this be that both the terminals are ground, but over here that is not the case? Um, hmm, well, forget it. Let's let's just delete this one. Control C, control. Oh, okay, my bad. Um, Control C and Control V. Over here we got our another which is D4 over here, but we want it to be D2. Okay, I think now at least now it should work here. Look over here. This is now I see the problem. Okay, I guess now it will work. Let's just change it. Okay, P1 and okay, B2. Let's zoom it up. Okay, it's still showing ground and ground. Uh, okay. Yes, I think I got the problem. I want to move this register over here. Delete this ground. Delete this. Delete this. Okay. Um, place the ground over here and move it further. Move it further. Okay. We but okay. Now I think this is fine. Control S. Control S. Now let's see. Yes, update net. Okay, fine. Uh, I'm very sorry. It was again a minute mistake from my side. Okay, so okay, now the main problem is connecting this to one, right? Let's just delete this alt wire. Okay, what is this? Okay, my bad. Yeah. Okay, I have to connect this and this B7 and A7 and A6 and B6. Okay. So instead, just move over here and do this way. if we move over here, um, say like this, okay, and then uh, this one is over here, okay. Wait a minute, let's just shift it um, on the wire. Place this one to this one. Um, I should be shift to this um, R11. Doesn't do that. Okay, this is not right. That's fine. Let's move from here. Okay, this is done. Now this is okay. So I need to move my D3 over here. Okay, this is fine, I guess. R10 is over here. Okay. Anyways, okay. Uh, Similarly, okay, D2 is over here. Let's place D2 over here. Hmm. Okay. Now, obviously both of them will go to the ground. There is 5 volt, which is okay. I also need to connect those 5 volt and I have to transfer this to there. Okay, certainly this will prove a little. Okay, I have an idea. Let's shift this over here. Okay, now let's see. Um, wait a minute. I will have to change the width to 0.4. Oh, wait, what happened? 0 0.4. Okay. Ah, from here to here. Okay. It is not working. 0.4. Okay, for some reason it is still not working. I guess move it. Okay, just delete this one. Okay, now that's fine. Again, change it to 0.4 and simply move this one. Okay, wait a minute. Uh, Abhi, okay, now we have to connect this one, this terminal to um, 0.5 volt. Okay, the main problem is okay. So I'm thinking, let's just move it to the bottom. Oh, wait a minute. I will again have to change the hmm, its length. Okay, over here, all stop this to this. Okay, now as you notice that the line width has changed. Let's change it back to 0.4 mm. Uh, Similarly, this one, change it to 0.4 mm. Okay. Now that this 0. Sorry, 5 volt is done. Now let's see, which is simple. Connect ground to ground, and when they wait a minute, ground to ground. Okay. Now in USB, um, the 5 volt is still left. Okay. Um, Fine. Now, okay. Uh, Now, we have to connect this one to that one. Okay. Which is okay. This is fine, I guess. Okay. Uh, this one is left. This two. Okay. This one is a little bit of a problem. Nobody bottom. Okay. Okay. Uh, just move this register 9 over here for simplicity. Also do. Okay. Done. Um. Also this just ground connection is left. This is also done. Uh, Now in USB, this, this to this, as much as I can see, wait a minute. So now, till the only, okay, as you can see, this ground is not yet connected with the bottom one, right? So again, we'll do the same thing, move it to the bottom and shift it over here, move back to top and simply done. Okay. Now all that's left is just the differential pairing of USB D minus and D plus, which will move from here to here. Okay. And yes, D minus is on top and D plus is on bottom. Okay. Uh, the shortcut for differential pairing is Alt D, right? Yes, the track weight is 0.4. All these are the track properties and the rules which they will be following. Node, do you want to pair? Yes, we want to create. Um, positive one is USB B plus and negative B minus. Okay, apply, confirm. Okay. Now you can see from here, this is done. As you can see, there is no violation of DRC, and you can see that over here in the column of match the rule, it is in a very small green part, which means that our differential pairing is very nice. I mean, it will work very perfectly. In case it is in the it is red or it is not following the rule, then you will have to bend this tracing in such a way that it will match the rule. Okay. Uh, for that, there is a hmm, one option of tuning this differential pair. Okay, which can be done by Alt A, I think, from here. Oh, wait a minute. Um, hmm, Anyways, now that our USB connection is completed, mm, let's move to bottom side and complete this SD card connection. Okay, for SD card, as you can see, ground info will be 3v3. Okay, the first one is simple, which is mm, ground over here, Alt T. This okay, and now come back to the bottom. As you can see, there is this one Miso, there is this one Mochi. It- over here. The only problem is this back tracing which we did for USB. Okay, 3v3 CDCS Mochi Miso. What about CDCS CLP? Okay, let's start this with Miso. Okay, this is a bit of a problem. Anyways, right, is over here. Okay, this is done. Uh, Mochi, as you can see, there is bit of a struggle over here. Hmm. Let's analyze this properly. You can see CLK is okay. CLK will directly go over here. Okay, um, that is fine. Okay, so we can do one thing. Um, no, move out. our tracing a bit. Well, let's first start this one. Okay, okay, perhaps like this, it's better. And then, take this register over here, come back to fire. Now, 3v3 is there. 3v3 we can do this. Um, then there is, okay, Miko is connected, no worries. CL2 is left, right? Okay, so this will be better. Check to top and okay, CL2 is done. Um, Now move back to the bottom. Next one is Mosi. Okay, Mosi is over there. Uh, Again, that will be a bit of trouble, but no worries. Also stop. Wait a minute. Hmm. I think this should be deleted. Get it? Hardwire. Move it little further. Okay, this stop. I should move it a little bit over there. Wire. Okay. Mosi is done. Now the next one is CD here. Um, okay. CD here. It goes. This one will also pose a problem because we are trapped over the CD here is trapped. So wait, the only option which I see is shift this one over here. Okay. Yeah. So shift this one little over here. Perhaps now it should work. Um, we are gonna keep this here. Um, okay. Now from here onwards, up simply from hmm. Okay, now this is also done. CDCS, Moshi, CLK, Miso is Eric Miso, okay, Miso is over there. Uh, let's go back already. And okay, now this is done. Uh, coming back to the bottom, I have a problem over here. That is this one capacitor. Okay. Want to connect it to 3v3 and ground. Oh, but let's see, this is C11, right? Uh, C11 is to VDD. It has to be close to VDD because then only the capacitance is useful. Otherwise, it wait, that is pin 4. Okay, this one. Then no, nothing that I can do specifically other than this. Okay. Hmm. I think that's fine. Let's just connect this one. Okay. This is 3v3 and hmm, it's better to okay. Okay. Alt tab. Okay. No, this is the idea. We are trapped over here. We will have to delete this. Okay. The only option is to connect it to alt tab the bottom and okay. Now that this 3v3 is connected and this 3v3 is also connected, on that left is for this 3v3 will be connected over there. Okay, I guess this can be done through via. Let's move to top. Also I have 3v3. The bottom or top, bottom. Okay. Going back to top. Now, as you can see, this ground is open. Okay. Let's set it. Hmm. Hmm. Okay, wait. As you can see, this one is connected to this. So, through this register, our backup option of UART communication through GPS is used. Okay, on to her. Hmm, that's fine. Yeah. Um, I think perhaps we should move it Let's say what? Okay, that's fine. Next 3v3. Let's connect sound. Okay. Uh, this is sound also our. Okay, it is not here. Um, this one is connected to UFL. Similarly, okay, okay. Ground to ground. Okay, that is fine. Ground to ground is connected. Um, hmm. Okay, this is ground also connected. These two grounds are left out. Yeah. Wait a minute. I think this positioning of capacitor is little bad. Okay, well, anyways, L1 is over here. Hmm. But what is this? This is connected to this one. No. Hmm. Okay, then this is fine. But the main problem is this is connected to the not much of a problem. But, hmm. it- Well, that is fine now. Simply connect all the rest of. Hmm. Well, uh, this is it. Now, all the rest of the things are just as we did. There is nothing special. I'll just have to connect everything as we've already done in schematic. Okay, connect ground to ground. Okay. Well, as you can see, that this is little bit troublesome. So we can simply change. Okay, this is T2, right? Let's go to schematic. Um, here is T2, I think. Right. So, instead, delete this and add the net label. What we want? Okay, we want first one to be HDAC and second one to be HCLC. Basically, just to interchange those two. Okay. Okay, wait a minute. The first one was HDAC. Okay. Let's name it HDAC. Okay. Similarly, next one, and this will be HDA. Sorry, HCl. Okay. Hmm. Just save it and apply the changes. Um, okay, so now it is much simpler to do the connection. Okay. Hmm. Wait, another thing. Important thing which I forgot was we will have to do differential pair for RX and TX also. Okay. But now, as you can see, these two are crossing each other. Um. Well, anyways, I'll have to figure it out somehow. Well, you can see N and here. Well, let's just first do the differential pair. Okay, confirm. Okay, TX GPS and second one will be RX GPS. Okay, apply, confirm. Hmm. Unfortunately, we will have to move to this. Wait. Hmm. Okay, let's delete, delete, Alt D. Okay. Now over here, just move. Hmm. Now let's just leave it at that. Alt B. Yes, it's crossing is also a problem, but oh God, not this way. Um, well, this is pretty bad. This cannot be done right. I will have to think something about this. Hmm. The only option is to mhm, do it this way. Okay, now you can clearly see that these wirings are very well obviously violating the rule. Uh, so, okay, now just as we saw that as you can see that this differential pair is out of the rule, okay, it is violating the rule. So we will have to fix it. Now the one way to fix it is to do the tuning. Okay, now for tuning, um, you will have to do Shift A. Okay, now Shift A. I will have to select the starting point and ending point as well. As you see, as you can see, depending on changing the by changing the length, we can easily match the rule, right? Look, hmm, let's do this in bottom also. Okay. Hmm. Fine now. As you can see, this is done. You can say it is almost over now. Now all that left is just few tracings of other components. Okay. So let's just do this quickly. Okay. Pyro 5 volts. Hmm. Yes. Okay, wait. Hmm. Okay, now the thing is this wire has to be of 0.4 mm because it is carrying 5 volt. Similarly, this whole wire also 0.4. Okay, now alt wire, change it to 0.4. Um, this way. Similarly, this, uh, this, and this is done. Okay, pyro 5 volt is done. And now back to normal. This is here and 3 and 4 and 1 and 2. Okay, now R17 is from M1G. Okay, I will have to change it a bit. Um, C12. Where exactly is C12? Second one. Okay, C12 is near 3 and the ground. Okay. Hmm. C12, it should be over here. Physically, where? Um, Again, this is pretty bad situation. Wait a minute. What is? Yes, wait a minute, where it's still uh, this is important actually. So, so just delete this one. Move it little bit over there. Okay, delete this one. Move one word. 2.4. Okay, let's get hmm. 5, 3, 3. And okay, that is done. Um, now as for this, it should be like this. Okay, wait a minute. Modifier. Hmm. M1G. Distributor. Distributor. Connect this down. Okay. All right. This ground and this ground both are not connected. Hmm. Okay. Well, this is SCL and SDA pull-up. Okay. Where is SCL and SDA? These two are over here. Okay. R24 and R25 both have to be this side. Uh, M2G, well, this one is over here. Hmm. Both is different. Okay. Connect this. Just and then this is ground. Okay. M3G and M4G are left. Or let's just do it from here. M3G. Okay. Then understood over here. M4H. This is much like possible. Hmm. M4. Okay. Now let's connect this M4 also. Okay. Uh, with this, let's check this one. Alt W. This digit. Ground to ground. Hmm. Okay. Uh, here M3G. Okay. Uh, this is fine. Connect this one. Yeah, this one, um, ground to ground. Now, uh, yeah, see which one is remaining. Alt B, Alt B. Okay, simple. Hmm. Okay. Hmm. This is a boot button, right? R14 and 15 are together. Where is boot button is what you are at? 14, 15. Okay, fine, I understand. This has to go to 3v3. This will go to boot. Okay, this is fine. Over here, this, boot to boot to boot, 3v3, to 3v3. N to N. Hmm. Okay, connect ground to ground, ground to ground. Now, now that I think of it, mostly everything is done. Hmm. Except for SQL and FDA. Okay, let's next one. Okay, okay, wait a moment. This was a mistake. Hmm. Right. Hmm. This would be better. Wire, connect SDA, connect 3v3. Okay, now SDA and SQL, as you can see, this is connected to. Okay, fine. Okay, wait a minute. Let's shift this. Um, there, okay. Wire, stop, function, okay. Let's see, HCL is connected. Now, this SDA and HCL are yet to be connected there. Okay. Obviously, this is going to be a difficult one. Alt B, Alt C. Okay, this is where this is where I'm stuck and I cannot do anything over here because okay, my bad, I direct changed, but not this. Okay, yes. Mm, Wait a minute, let's just delete this one. Yeah. Hmm. Okay. Now, yeah, what we are actually, see. Okay, this is also done. Now, the very important challenge is taking this to VM over here. Let's start the journey from VM. As you can see, problem is this one. Okay, then now it is not possible. Hmm. Okay, now these five holes are not connected with each other. That is a problem. Hmm. Let's let this graph this one. Okay, there is no other way. It has to be 0.4 mm. Wire. Again 0.4 mm. Connect this. Okay. Ground to ground. Well, as you can see, this ground is stuck. This is all right. Only this ground is left now. Okay. Yeah, but you can see. Okay. Already. Already. Just shift it to the future. Now the next is SDA part. Uh, hmm. Uh, Now again, we have to connect this SDA. Hmm. I think it's pretty simple. Hmm. Another problem which I can see right now is this testing terminal of CMISO and CLD. Right, okay. See, that is almost there, okay. Hmm. Move it to the bottom. Already done. Okay. Now let's see. Mochi. Um, I think for Mochi it will be little difficult. Hmm. Over here, shift it to this side and move it back to top and this. Okay. Uh, Now let's see CL2, which is over there. Okay, CL2 is also difficult because there is no way we can move from this side. Let's see miso. Okay, okay. Now the next one is CLK. Oh, hmm, hmm. This is change. Move back to top. Okay. Now, as you can see, almost everything is done except for this one. Uh, EN1. And EN is certainly very difficult to route right now. Well, let's leave it over here. Uh, Try now. Okay, let's just update this for now. Okay, okay. Hmm. And finally, this is also done. Let's delete this one. Okay, let's check the DRC. Only 3v3 and ground connections are left, which will be completed through hmm, via okay. See 3v3, 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 GMD, 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 GMD. Okay. Hmm. So now let's the very last part of this video series will be layer creation. Wait a minute. Let's see. There is a mistake. What- Okay. That is fine. Hmm. Then now we are on to the last part, which is layer selection. Okay. Okay. Uh, Now we are on to the last part of the video, which is layer management. Hmm. So, layer manager, and we will select four layers. Okay. Okay. Now, once the four layers are applied, we can see over here we got the four layer. Uh, Wait a minute. Hmm. You can see this is copper area. Okay. Then we will select rectangle and fill out the whole copper area. Okay. Now you can see the detail. Type 1 copper region 4-1 top layer. Uh, I want top layer to be 3v3. So basically it is like top layer is 3v3. Um, in between those two layer will be ground and last layer will also be 3v3. Okay, confirm. Uh, it is loading. Okay. Now you can see top layer is done. Now for the middle, wait a minute. Let's change the color. I don't like the color of this. Keep it yellow. Um, Keep it pink. Okay. Ah, Now for the middle region again, we will select. Wait a minute. Uh, This is inner region. Inner region will be ground. Okay. Confirm. Okay. This is also done. Now third region. Again complete fill out. It is also ground. Confirm. Okay. Uh, Now the last region is again copper area. Fill out completely, and this one is 3v3. Okay. Now coming back to the top. As you can see, this is completed. Okay, I forgot to put the wires. Okay. Hmm. Now let's see which one are remaining. Okay. Similarly, as you saw the how to put the layer. So, okay, let's change it and Alt V. Okay, now it is completed. You can see this is ground. This is the via of ground. Now, similarly, let's see. This is 3v3, right? Um, okay, I will have to bring this also to the via, and this also will be a via. Okay, Alt V. Okay, I stop. Yeah, then similarly coming to the top, this one will also have a via. Okay, now this is another 3v3 which is left. This is done on ground. Okay, this 3v3 and all the rest of 3v3s are not connected. Okay, so again we'll put it here and Alt V via. Okay, and now again coming to the top, this 3v3. Okay, this 3v3 is also separated out, so let's put one via over here. Okay, now coming to the top again. um, Now that I think about it, I think all the 3v3 connections are done. Now ground one are left. Okay, as you can see, this and this, both grounds are not connected with each other. Okay, wait, perhaps I can Alt B, Alt T, and this. Okay, uh, now if you see the ground, okay, this one, uh, Alt B. Okay, this one is remaining. Uh, you can see these all are pretty far away. No problem. Put the wire over here. Okay. And then this ground. Okay. Wait a minute. Alt B, Alt T, and okay, this is connected now. Um. Okay. Uh, hmm. Sorry. Hmm. I can see only this is left. Uh, then there is nothing much you can do over here. Let's put it to wire. Okay. Now again back to the top. Which one are left? Okay, this one is over here. Wait. Blue. Uh, let's see this. Okay. And I thought this ground is still left. Um, hmm, hmm, okay. Now, hmm, this is ground is done. This whole ground is connected. That one is also connected. This whole ground are also connected. Okay, so I think this is complete. Let's now put the proper regions again and finally check with DRC. Okay, this is top layer which is 3v3. Confirm. And now next is inner layer. Again, inner layer over the whole PCB. This will be ground. Okay, and then second inner layer. This will also be ground. Confirm. Hmm. And finally, this is the last layer. Last layer. Um, it will be 3v3. Okay. Uh, coming to the top. As you can see, there is no net left. So I think it is completed. Let's check the DRC. And as you can see, all the errors are done. And with this, finally, our PCB design is ready. I hope you will get to learn a lot from this video. And thank you very much for watching the whole video till the end.